All right, good morning, guys. My name's Kevin Nassery. I'm talking about security prioritization in large organizations. Most of this stuff applies to kind of every organization, but some of the problems that for small companies you might not have to deal with as much, or it might not be as visible yet. But if you work for a small company, or if you're a consultant who goes all sorts of places, I think you'll see a lot of these issues come up in pretty much any incarnation of where people are trying to secure kind of enterprise business. Specifically not like, if you're, I think there's some advantage in terms of if you're a company that sells security services, you kind of have a cultural advantage there, or if you're a company that perhaps makes some type of product. But so my background, I've spoken at a couple of conferences. I spent about 10 years just focused on actually infrastructure architecture, engineering, systems administration, storage engineering, network engineering. But I'm kind of come from an old school background where when I did systems engineering, it was still security engineering. I mean, we bring that to our work. Specifically, I spent 4 years as kind of the chief infrastructure architect for a large online marketing firm, Classified Ventures. We ran cars.com, apartments.com, so I ran the central engineering group for that, both engineers and architects. I spent a couple of years after that doing just kind of security consulting for a small firm, but we went to large organizations, Fortune 50s, anything from healthcare to retail sales, all sorts of things. Now I run a small team that's internal penetration testing and security research group within a large bank that's in the U.S. Some people call it a U.S. bank. So, and we're a new team, and some of the ideas that come from this, none of this material is really specific to the bank or even, but my job at the bank definitely reflects some of these ideas I've had over the last 5 years. So I'm definitely not breaking any NDA or speaking specifically about the bank in any of these occasions. If I do have an opportunity to kind of provide some specific story or in the discussion section, maybe we'll get into more about specific stuff, not about the bank. So the problem I want to talk about is, the security problem of making things, perfectly secure it's kind of futile. We know that, especially in large organizations that have gone a long time with their business not being, security maybe not being a priority, but even if it is a priority, it's a hard problem to solve. So how can a security group of any size who faces a challenge of making things incrementally more secure or more secure at an organization, how do they make the biggest impact? So we'll talk about kind of problems that I've seen with organizations and kind of attitudes around security, as well as just the reality, kind of some more tactical stuff at the end. But what am I talking about? Well, organizations have kind of decades of doing the wrong thing and gaining security debt, whether it be unpatched system deployments, a large diverse code base that hasn't really been security. Maybe they didn't even have a development life cycle that involved security until the last 5 years. It was, and even 01 was kind of the start of where people really started to focus on application security from that perspective. And generally we create still new problems faster than we're fixing the old ones. So what does that kind of look like? And for either of us know these numbers are kind of completely made up, but in the green, maybe is a measure of our remediation efforts. So how many issues are we fixing? In the yellow, starting for 20 years, we had some security issues inherent to what we were doing as kind of connectivity and emerged, the exposure of those issues, and just the amount of new technology coming into a place. In the yellow there kind of accumulates. So if you kind of look at if you guys are math people, the integral or the number of accruing vulnerabilities over time, that's just getting bigger. So how do we kind of make an impact on something that's got that kind of momentum? So we'll start with kind of going over some of the things that I think are wrong, and I'm not going to really speak about specific technology problems. We've been talking about that a lot, and one of the things when I come to conferences I see a lot is we'll spend a lot of time talking about new ways to break systems, and then I go back to work and I see a vulnerability that could have been patched in 2004, or a system deployment that just has fallen off the radar. It's like somebody's never turned off, and those problems tend to make some of the largest burden of systems security or just in general enterprise information security that we have. So what are kind of the common problems that I see? Well, we kind of stop thinking critically about problems and their root cause, right? We go very tactical. Vulnerability management programs, maybe that's kind of the biggest instance of that, where, okay, we're trying to measure a central problem, but then our remediation strategy becomes super tactical, like, okay, let's go through and give this data to a system admin who's going to try to patch 100,000 vulnerabilities we just discovered overnight. And maybe if we're dealing with a large enterprise where you have 60,000 instances of, a server instances or something like that, even new vulnerability data is going to swamp you. You have to be more tactical. And a lot of times the systems engineering groups aren't really positioned very well in terms of having the central builds in place. A lot of times they're cloning their problems now with virtualization and the kind of the proliferation of system images. So we kind of operationalize the wrong solution, right? I mean, it'd be like if we went back to developers and just opened them as bugs and never tried to make a secure development lifecycle is kind of the instance of that. We fix bugs is a good strategy for people who are already trying to include security in their system, and that works generally for companies that have kind of a very secure culture. But a lot of times we don't do the analysis of finding the systemic problems that are leading to bugs kind of as a symptom, and then going back and trying to develop a central solution or some type of single impact that can reflect over the enterprise. We have very poor return on remediating individual issues. We underestimate the complexity of systems, especially systems that start small and grow big. We don't really model the security impacts of adjacencies and escalated impacts very well. You could have a PCI application that hey, I need to increase my system security on this. I'm going to start with a build and I'm going to patch on this schedule, and this is kind of going to be my response plan to an advanced persistent threat or something like that. But then at the same time, there's a system you didn't even know that sits right next to it somewhere in the transmission path that can do kind of a simple layer 2 attack and kind of have a lot of leverage there of your data. And we do that all the time. We think security problems are simple until we really start to look at that. And I think that comes from the culture of people who are taking 10 minutes to come up with a likelihood times impact score for a system. They don't even understand. I mean, when we do this as a kind of internal penetration testing, and we do beyond penetration testing, we'll do basically design review, make sure that the design, reverse engineering the actual system in place to make sure that the design is correlated with what's in place, and we'll find new issues. But it's a hard thing to understand the full security model of an individual system or application, let alone the interconnection with other system adjacency of shared resources and stuff like that. It's very hard to come up with a good 10-minute score. Distributed problems are harder to solve than central problems. What I mean by that is, a lot of times we'll take something that's authentication and we'll say, oh, well, we've got a new system and it's easy for us to deploy a new authentication mechanism with that system. But then we're accumulating the complexity of managing 2 authentication systems. Later on, we might want to try to synchronize them. And, we have an advantage when we are adding the second system to try to centralize our problem. And generally, we should try to do that. There's a lot of distribution in large enterprises that don't need to be there, and it consumes a lot of our thought time and acting time in those spaces. And we marginalize, when we stop thinking critically and allowing the kind of creativity for good problem solvers to solve problems in intelligent ways, we just kind of marginalize our good people, and eventually they'll move on into things where they can be more creative, where really they should have been trying to solve difficult problems. Another thing we do way too often, and this is kind of corresponding to that kind of think to act ratio, maybe we should be spending 60% of our time thinking and 40% of our time acting versus the reality of that in most organizations, which is like 95-5. Like I've been in situations where I made a comment and I was immediately supposed to write a paper about what I'm talking. It's like, well, let me cultivate on this issue and come to you with some rational thoughts and back my stuff up with some good empirical data, versus trying to make an action plan, immediately whenever we kind of discover a new idea. We don't get enough time to really pursue what we're thinking on. But We focused on the known security issues. Like, we know we're bad at patching things in some cases, or we know we're bad at managing secure code. But there's a lot of issues that we don't explore, right? We tend to, once we have that field of probably too much to work on, we stop enumerating the space of new problems. And that is probably where most companies get hit the hardest when you look at external vulnerabilities, or when you look at real breach information. You get kind of that situation where, oh, it was just an omitted control because we never even looked at that security issue. There's very little internal security research, and I don't mean in security research in the sense that vulnerability research. We don't necessarily need a lot of new vulnerability research to attack things within an enterprise that is generally not very good at security, right? But what I mean by security vulnerability research is taking empirical data of what we're looking at and moving to systemic issues, and then moving to a new control perhaps, or improved controls. And specifically, it might not, we tend to overemphasize, and I think I might have a bullet later on, but if I do, we'll just skip it. But we overemphasize, resistive controls. Okay, how can I prevent an attack? Where in a lot of cases, you're dealing with the debt directly by trying to prevent an attack. Whereas if you move to a detective control, you're very rarely facing the same level of burden in developing a new monitoring control or a new way to detect. If a person sitting in the cube farm is not supposed to talk directly to a server farm, maybe we don't have to wait for that full deployment of a new firewall or ACL control to control that, or some type of network admission control. Maybe we can immediately go to the flow data and mine that for instances where it's happening. So being better at kind of detective controls, I think, is probably where we don't spend enough time. And then when we have a lot of problems, so we'll generally look at one of them at a time, and it hurts our ability to understand the impacts between problems or in between systems. And we kind of focus too narrowly on things that we already know are issues, so that we're not expanding, we're kind of putting blinders on, which I think is probably things that people trying to prove that a security program are working, that's their way to do it, right? Okay, well, let's focus on this very narrow slice of data and make a change in that, and see the measured improvement in that one particular area where it's probably not even relevant to the overall security state of an organization. Or at least a lot of times it's not. Number three, we deal with this idea of, a lot of times, I think Jim O'Gorman's a really bright guy, and at the last LayerOne he gave this talk, and I was really on board with it for maybe even a year, where he kind of took the instances of pen test findings he was looking at and brought it back to, this was a policy failure. Well, you can write a policy to prevent anything if it's abided by, but we know that people are our weakest point. We know how effective, and Jim knows more than anyone how effective social engineering attacks are. He does a lot of work in that space. He's on the social engineering toolkit. We have that false hope in policy control of people. We know people are the weakest link, so how can any control based on their behavior be helpful? I'm not saying that it's not good in terms, it's specifically good in terms of technical standards and managing technology groups to a set of requirements, but policy should be also developed in terms of what can we actually test for in terms of compliance of policy, so that when people aren't abiding by policy, there's some technical control in place to support resolving that issue. And I think, kind of a good, in terms of security awareness training, it may be important to do, but I don't think it's effective yet, especially in the way it's done. And I think a good case study, it's not restricted to security, but if you look at the DARE program, which has been in place for 30 years trying to keep kids off drugs, it's still not effective. There's studies, especially in 2007, the DARE program actually kind of admitted that, hey, we haven't made a big change, and they're going back to work on some of the issues. But I think it's the fundamental. You can talk to 8-year-olds through 11-year-olds as much as you want about these types of problems. When they're 15 and the culture is different, they're not going to abide by your rules. They have no reason to. And likewise in the work, everybody's trying to do the best at their job, or hopefully a lot of people are, and that's generally where policy controls fail. Nobody can use USB media here. Well, okay, if you don't have a technical control to back that up, and the first time it's easier for somebody to do that, they're going to break that policy. I think generally, number 4 is I think security metrics are being abused. I agree that they're really important, and I think when you look at the argument for security metrics, it's almost unbeatable in terms of how are we measuring our success in certain spaces and stuff like that. But what do we really use security metrics for? You look at these metrics teams and teams that are dedicated to coming up with ways to measure the performance of security operations. And what do? Well, they try to make an argument for increasing security spend. And when you have kind of statistics and the leverage of numbers to obfuscate real data and encapsulate it in different ways, what are you going to do with it? You're going to lie with it almost every time. And I think, if you have a security metrics program in place and you want to know if it's good, start looking at the metrics and see if you can reverse engineer them. See if you can talk to the person who developed the metric and understand what it actually means. The other thing that maybe not as directly malicious or kind of, nobody intends to do this, but we develop the metrics kind of in a bubble, and then we just lock ourselves into them. We don't QA them, and we don't iterate them like we do other pieces of technology. So rarely do they end up being at the end of the cycle or the end of the data period that you're concerned about, useful for decision making, because, we did that when we were starting the vulnerability management program, but we didn't know what we were going to be good at and what we weren't going to be good at, so it doesn't really measure our performance very well. So they lack transparency. It's hard to understand some metrics, and in a way, they're trying to essentially encapsulate very difficult problems into numerical data so that a CISO or somebody can make more decisions with less raw information. And I agree with that in theory, but if you're not doing a good job at that, then the decision-making quality of the CISO, anybody can make decisions based on picking numbers. It takes good people in those roles to make good decisions regardless of what the numbers are. I can always pick the higher of two numbers, to make a decision. But that's not really that useful in most security metrics programs that I've seen. The last part, and I see this growing more and more as people get, because it's a wonderful, compelling argument for security metrics, as people get traction with security metrics, I don't know if you guys have seen it as much as I have, but they need the data coming out of operations, and operations is rarely instrumented well enough to get the data they're looking for, partially because some of it's just not valuable data anyway, and it's maybe part of that transparency and lack of operations. But it certainly does, on occasion, overwhelm our acting ability, right? We have an operational duty and we have a security charter to actually impact change on an organization, and maybe we get limited to doing that a fraction of the time we should be by the amount of overhead that it takes to observe changes or re-instrument to gather new metrics and monitoring new things. So be aware of that. This number 5 thing, this team charters are often not conducive to security insight. You get groups, most organizations are just kind of organically chartered where, hey, a new thing comes up, maybe we need a cloud offering. So a new team spins up and they're the cloud team. And then somebody says, well, what about security? So we get another team that's cloud security team. And that's, you get platform groups where Windows platform versus Unix platform. You get middleware application groups spinning up in some companies where, okay, one person is not even, doesn't even understand the security model of a system deployed with all of its application content and middleware. That responsibility is broken up over maybe 5 groups and hundreds of people. So it's easy, it's very difficult to model the state of security like as a life cycle. Okay, I want a secure build, I want a patching strategy, I want to be able to package and deploy middleware components and patch those as well. I want to have a code deployment, and it's very easy for something to get lost if there's not one person who even understands that, let alone responsible for it. So, the nature of kind of separation of duties is great to balance security, but a lot of times in terms of the reality of doing security, 80% of it might have to get done within the operations lifecycle, and if you try to pull it out or pull it away from a group that's making day-to-day operational changes, then you're going to start to acquire the debt of, oh, we made a mistake here. Who's going to come back and fix that later? And it's very hard to get charted. So I generally think, although separation of duties is a long-term security concept, and certainly has its value, especially with, I think the reality is it creates as much problems, or a lot of times it creates, a lot of problems that we don't recognize in terms of hey, nobody was chartered to patch that middleware application. Somebody was chartered to deploy it, somebody was chartered to make sure it's available, but who's maintaining it? And that's the kind of debt we deal with when organizations are not chartered around security. So we need to do those exercises where we say, hey, here is a system security, here's what we need to do in the process of system security from start to finish, and here's who's responsible for doing it. And if nobody raises their hand for a particular piece, then instead of starting a new group for that particular piece, maybe we should figure out where to place that piece within the working charter, or recharter eventually. If you look at teams that are chartered, you get more overlap in kind of skill set here sometimes, but if you look at, okay, this team is responsible for end user operations from start to finish, including the security, maybe that's a potential alternative that in general, at least you have a smaller and less complex set of systems that you're worried about addressing the security on, and just from a life cycle, maybe easier to model and manage from a security perspective. And this is the last of the problems, and we'll talk about hopefully moving forward. But the culture of process in place, and I get this a lot, is we recognize a problem, we even come up with a good solution, and we've seemingly fixed maybe a small problem. We tend, in technology organizations as a whole, and security is certainly a part of this, we have this culture of process where everything needs to be controlled by some process, and it kind of, in speaking with the creativity, it can kind of make life, not every process or an individual process is not good at solving a wide array of problems that we're dealing with on a day-to-day basis. It's just ineffective and inefficient, and I think we see the results of that, but we don't, tend to think about it too much. And it, by design, limits creative people. I was in a engagement a couple of years ago with a large managed healthcare provider, and I was working with the director of enterprise architecture, and they had a security architecture group and an enterprise architecture practice that was very formal, very kind of paper architects on the enterprise side, and they were looking at trying to build security more into the our enterprise architecture lifecycle. And we were going over just as kind of an exercise, what is the goals of this project? And his first goal was like, limit unnecessary creativity. Okay, well, I can do that, but I think we're going to get more value out of everyone if we embrace their creativity, especially in terms of solving these difficult problems, than if we give them these, essentially they're building reusable building blocks as much as possible, and I think when it comes to the actual engineering and deployment, it makes your EA practice, if it ever was really solidly important to your technology program, it kind of does marginalize it when you're just producing the same component models and pictures every day. That's kind of what some EA groups, and I don't know if anybody has been a part of EA before, but I tend to think that it's definitely a practice right now that's in trouble. If you're ever 15 minutes joining the LinkedIn EA Enterprise Architects, you'll see the same 6 questions of what is EA's role, and nobody, it's really hard to determine because it's kind of an amorphous, and at this point it's just kind of a way for certain people who weren't really great at engineering to kind of go into basically people who aren't good at engineering, it's kind of a career path for them to get better at architecture in a lot of ways, or to get paid more. They're not getting really better at anything, but they're dealing with problems in such an abstract way that how does it help the people on the ground build and deploy systems and manage security issues? It's hard for me as somebody who comes from a way more engineering-based and architectural role to understand how much value is there. So moving forward, we've got some of these problems that we deal with when we operationalize the wrong project, and you see this a lot in maybe identity and access management groups. Okay, a big old enterprise has 47 discrete systems of authentication and authorization, or however many they are. So how many people are out of the 200 or 400 person IT security problem? How many people are just provisioning accounts? Like, that's a huge problem that I see amass with larger organizations. So, you have a lot of people, maybe too many people doing firewall operations. Maybe they're ineffective at it, or their call schedule is such that they have a large body mass. But if you take the time to invest in kind of security research to solve some of those, maybe move more towards automation and you know, single sign-on solutions, and just figure out a way to transition, using the creative people that you have, figure out a way to solve some of those problems with a technology-based solution, and to move away from the operational burdens that you're, because those are like, you know, reoccurring debt. You know, every time that a person does something that can be repeatable, what are we gaining out of that? We should invest in kind of the development time, and that's also too, a lot of these companies aren't product companies, so they're very bad at building products that help with their security problems. And I think we need to hire people that are generally good people at solving and automation and stuff like that, and really invest in terms of security development in that space. The other thing, it certainly helps enable that culture of critical thinking and creative problem solving, which I think is our #1 tool against, you know, against this kind of inherent mechanical disadvantage that we have against the security problem. We're improving understanding through root cause and failure analysis, so finding the systemic causes of problems, not treating the symptoms of security issues. And you know, like I said before, you know, security operations in terms of when we take that out of the general engineering practices, it's just more burden for the specific security personnel. We need to push operational security into technology operations, and reserve security for security, you know, this type of security research. B, audit is a big part of this. How do we understand that our processes are effective and working? And metrics, good metrics. And I spoke about this earlier, but this is just where resistant controls are difficult. Think about developing detective controls, and not just deploying IDS, but developing a custom IDS rule that, you know, behaviorally in your environment something's not supposed to happen. So how can we detect it, and how do we alert on it? Whether it be log data, flow analysis data is being, you know, a lot of people are kind of looking at anomaly detection tools from flow data, which is like, hey, every, you know, network transactions to your network. That's really a good approach, but the problem is that maybe you're, you know, it's a lot of it is almost too expert system and, you know, baseline exceeding oriented at this point. Think about some practical things you can do. You know, if your network engineering group is reserving address space in every subnet, you know, they're reserving, you know, 7 addresses or something like that, and they're only using 3 of them, deploy a flow rule that says, hey, if anything ever hits .7 in my network, alert, because somebody's, you know, that's generally, or at least log and review that data. You can, that's a really good way to identify, you know, scanning and reconnaissance attempts of people trying to attempt to targets that you know will never exist, or people trying to use protocols that you know shouldn't exist, is good indications of network security reconnaissance. Yeah, I mean, flow data, and also, you know, you can, once you make some central investments in terms of, hey, oh, we've got a kind of robust, you know, flow aggregation architecture, we've got a good central logging architecture, and we've got a good, you know, if you don't have a good IDS architecture, at least a good packet capturing architecture, you know, maybe using some of the, you know, the Gigamon technologies that we didn't have 5 years ago to have a good leverage point over some of that data. You can find things that, I mean, you can develop detective controls fairly easily using, you know, a pretty small central services group designed to having that data available. You know, it's kind of work that like Team Cymru does. I mean, that stuff's pretty valuable. Moving forward, you know, you got to take your defense in depth strategy from a security system, from a security perspective, whether it be for systems, applications, whatever it is. Theoretically, your organization has this, or at least knows that it's important. So if you develop it, but then model it across your technology organization to understand who really should be doing what parts, and like I said, make some key decisions to try to get the right pieces in the right hands, and people who are good at that and also are responsible for day-to-day operations doing some of that. You can definitely identify potential improvements in org structure. I know not everybody is in a position to improve or change the org structure, and that's probably, it's a difficult task. But how often does it change in big environments? It changes a lot. So if you can at one point articulate some issues and relate them to the org structure and kind of push that up to the decision makers, whether they take it or not, you've kind of done your part, and hopefully people will be informed by that and make some intelligent decisions based on the security problems we have. Certainly increase kind of cross-team collaboration. I know this is, you know, a lot of the problems we have are just because people can't communicate, and the culture is that of working on their own specific, not expanding the scope of people's operations. You know, you gotta, breaking down those lines are some of the biggest. Personal relationships really go a long way in solving some of the toughest security problems we're having. So, you know, working on that problem alone is one of the higher, the most valuable ways you can start to resolve some of these tougher problems. And increase interdomain technology knowledge. Security people doing this kind of work, doing penetration testing, doing kind of security research in terms of finding systemic issues, they need a pretty amazing breadth of knowledge and understanding how systems work at each level. You know, you need to build you need to have the personnel who can collaborate where they are out of their depths with people who have the particular expertise. One of the ways you can do that is definitely by increasing the kind of the security relationship into these operations groups, and saying, you know, then you're getting the advantage of, okay, well, they understand the network better than anyone, and they're tasked with this particular security duty. Also, I need their input when I threat model a system. You know, I need their input to understand what controls are in place to prevent, you know, certain issues, and also I need to have the opportunity to test those controls for their effectiveness. I really do think move towards a creative culture. You know, I think from an engineering perspective, you know, and moving away from those kind of process cultures, there's good examples of how it works. I mean, I think, and I've never worked there, but it seems like, you know, from what I've read, the engineering culture at Google is maybe a particular instance of this. They're certainly given 20% of their time to try to work on whatever they think is a, you know, a creative product idea or a creative idea. So I do think our people are both our most restrained asset, and then what they're capable of doing that we're not letting them do could be an incredible value to most organizations. So, and in fact, in making hiring decisions, I generally don't hire based on a particular skill set I need. What I'll do is I'll try to find somebody who has a enthusiasm and passion for some dimension of security, and I know that in our environment they're going to be able to apply that in an impactful way. So just building diverse teams of people who are passionate about it, and then have a particular diversity of strength, I think is important. So that kind of goes along with the first couple. Yeah, definitely, we don't need a process for everything. We can think things through reasonably and generally more efficient. When we start to apply these processes that are developed outside of engineering, in most cases, to every engineering problem, it generally doesn't end up actually getting used, and it just creates kind of more of a confrontation between business and technology. You know, definitely use, you know, I run a penetration testing and security research organization. There is a vulnerability management group where I work. I think these things are critical inputs in terms of empirical data and problems that exist. But we don't really need to penetration test everything. We need to do, you know, statistically significant samples and find the types of problems that are reoccurring, and then go back and do the root cause analysis to try to fix those in a central way. So moving that stuff upstream. It's not always easy, and we certainly do need to kind of triage major issues as they come up. You know, I'm not advocating that you don't patch a server that's exposed to the internet, or you know, if you don't deal with your you know, security code development problems quickly, but you know, definitely try to look for the most impactful change where you can make it, even if it takes a little bit longer to do it. This number 5, increase visibility into your security problems regardless of you can fix it. How do we understand what our biggest problems are if we start to kind of put those blinders up and not focus on the big picture? You know, if you have, you know, I've seen this before where people are restricting their vulnerability scanning and management solutions to only scan specific ranges of stuff because they just don't have the manpower to fix more than that. Well, we don't have a good indication of what the real problem is because you're limiting the visibility scope. We could decide in a much better way where to spend our remediation constrained effort if we had the big picture of security versus falsely limiting that. Another way you see that is when people kind of over-focus on maybe their assets that are in compliance, direct compliance scope. Let's only look at, you know, PCI scope servers, but maybe we don't have the network network segmentation to back up, and we don't have the technical controls to isolate those servers, then how can we in good faith just measure security problems with those servers if a server right next to it is going to be able to do a man-in-the-middle ARP attack on it? We need to start thinking more intelligently about the controls we really have in place and not limiting our perspective to make it look better than it really is. It's kind of the challenger, space shuttle challenger problem. Like, Richard Feynman writes this brilliant, it's one of the best pieces of technical writing ever written. And his major conclusion is that, hey, management had a totally different understanding of the failure rates of all these different components in the combined system because of the gap between engineering and management, the cultural gap of, hey, we want to make this look better than it seems or whatever. But when you talk to the engineers, he actually calculated, hey, 1 in 65 shuttles will probably fail. When you talk to the administration and use their numbers, it's like 1 in 35,000. So he was like, hey, how many shuttles actually failed? About 1 in 65. Moving forward, this is, I spoke a little bit about hiring, but I do think as you start to free up, if you can automate and free up those resources, and hey, that might be a kind of a cruel thing to consider, but especially when we hire people and new people, hire for enthusiasm for technology and security is a big thing. People will make up gobs of what they do and experience with enthusiasm, and I really believe that. Understand the importance of finding the root cause analysis, the origin of issues is critically important. So having somebody who's a capable problem solver and has some concept of finding, and it's not the blame game of, oh, who was at fault, it's what was the process that failed here to acquire this data, or what process control didn't we have to control that. You need people that can kind of facilitate remediation strategy. That spreadsheet of findings and an internal penetration testing team, it works for consultants. That's what you're asked to do. You're asked to say, hey, find every problem that we have with this web server, so you enumerate it and you find it, and you give them a spreadsheet of findings. Internally, we not only have to take that spreadsheet of findings, but we have to do the root cause analysis to figure out why those findings came into existence and find the best and most impactful changes that we can make based on our constrained resources. You need people that have built things, not everybody, but I mean, you need to have people who have built things, people who come from development background in order to be good AppSec people. You cannot just focus on finding problems in an internal security research organization. You have to help technology groups and other security groups start the process and facilitate remediation strategies. So sometimes it's more involved than others. Sometimes you might feel like you're handing a security, and particularly like when you're developing detective controls and you're coming to the security monitoring group. Well, that's a group that people have basically just been fielding the pager on IDS signatures, that product, the snort signature base. Okay, well, I'm coming for a new idea in terms of flow monitoring and finding an anomaly. You have to help them operationalize it, understand it, and ideally get them thinking in the same way about finding new ways to detect problems.
You probably get yourself out of work, basically.
Right, but we do have the luxury that it's a fun job to try to get yourself out of work, but we know that it's never going to happen. So that's the ultimate goal, but we will never have enough money, nor does it probably make sense from a business perspective for us to ever do that. So, and then good problem solvers. I mean, if you have an enthusiastic, good problem solver, I mean, if you have a really good auto mechanic who understands the nature of being an automotive mechanic, I think probably within a year they could become a good security resource. I mean, people who are if they had enthusiasm for doing it. But if you have a good problem solver and a lot of passion for the work, I mean, we see it all around us where people who are just getting into space within a year or two, based on the security community that we have, you can really excel in a short amount of time, especially if you limit or if you're focused on individual things, how to improve. So, I think generally what I'm saying is if you're going to spend a lot of money, put the money towards brilliance less than experience in general. So moving forward, how do we prioritize effort? Well, I don't think there's anything new here. I think we can get better at it. But understanding and modeling threat perspectives, large to small. So what I mean by that is, populations of threats. Well, I have an infinite number of people on the outside of my infrastructure, so I should certainly consider that threat perspective as one of the principal threat perspectives I'm considering in dealing with security problems. If I don't have good user segmentation, maybe I have 100,000 employees that all have access to direct sockets on my server infrastructure. That happens more than you would think in organizations. And you can see that most of the NAC products in the last 5 years that are designed specifically to solve that problem, even the good ones have kind of failed in gaining market share. People don't see this, management and administrative types don't really seem to understand that problem very well. And then there's other, if you're in a bank, what can tellers do? Model threat perspectives based on kind of high to low. I have a big group of people that have this type of access. How could they work outside of their responsibilities? And it's not just, from there you might be able to develop controls, but understanding the threat perspectives is kind of important to understand what security problems you're going to look at. And don't run from the uncertainty. If I don't know how a system works, I still should rate it in my scale of things to look at, and in fact, I should include it in the scoring of my threat model and ranking. If you have a GRC process that's one of those impact times likelihood things for a particular group of assets or something like that, what we've done and what I think tends to work well is to include, hey, I made this rating, and this was my amount of knowledge when I rated it, and that factors into the score. So I know that a direct way for me to change these ratings is for me to research it and understand how something works, so my uncertainty goes down, and my impact, based on that more improved or more informed decision, my impact and likelihood factors should probably change. But the overall score will decrease if they don't change. If I guessed at what it was and I was right, the score is still going to change because now I'm certain that I was right. I'm not dealing with any estimation that I made in my head. But a lot of times we don't rate something because we don't have enough information, and it just falls off the list of what we could fix because we're not researching it and we don't think about it. And then we've talked about this already. Find statistically significant problems, root cause analysis, and then where can we kind of start a remediation process. So if you can't, those are grandiose issues, right? And we're not all in a position where we even have an opportunity to talk to people who are decision makers in the organization. I certainly have been in positions where I haven't been able to influence organizations very well. So some more prescriptive commentary, common big wins. So the stuff where I go into an organization and I see it wrong with 50 groups, that's kind of what I'm talking about here. Controlling the user population network access control, like network admission control. I touched on that just a minute ago. I think that's a big space where people are failing. DBAs need access to the database servers, but your bank tellers do not. So how do we start to model? That's a big win in terms of investment in most large organizations. That isn't being done very well. Isolate and insulate legacy infrastructure. So we know that, okay, you have this mainframe and nobody really understands it, so that's okay, but can we encapsulate it in a system where the controls are simple and we do understand it? Can we put up some type of simple, system firewall to it? If it's a terminal-based application, can we put, a Unix system in there and you can get your terminal, SSH into it and completely, not air gap it, but kind of dual HONA Unix system. So that's the only method of accessing the legacy infrastructure. Can you do those types of things? Jump servers. Can you compartmentalize things that you do not understand and do not have the skill set or capability to understand with controls that that work? Can you insulate things? Turn things off more aggressively. This is a big problem for large organizations. I don't know how many people here are working in companies where they transition to the next project, but they leave the stuff on that was behind it, or there's like one very small piece of functionality that they need this, this Sun E250 from 1998 running Solaris 2.6. Why is that thing still on? Oh, well, it's the only server that can actually push code. If we turn things off and we get management support to be more rigid about turning things off, people will start to solve those problems pretty quickly. They'll deploy a new system that can deploy code a lot quicker than you would think they'd be able to. Identify which assets are under control. If you have a large server population, don't be afraid and to start working on a program where, okay, I want to know exactly the server population that I'm scanning that you're in control of and what you're not in control of. So how can we do that? Well, run this SNMP MIB on your servers. A custom, UCS and MPD if they're using it or something like that. You can just say, hey, this is security managed, last check-in date, today's date or something, a statically defined field. And then you can scan for that across, okay, we asked them to do an operation and they were able to inflect it over 60% of our server population. We know that those 60% of servers are at least in administrative control now. We might not have had that data before, and that's kind of critical data to have. And even if your vulnerabilities are evenly distributed, I know that I want to start my security impact on the servers that they weren't able to touch first. So they need to get those more in administrative control and compliance. Rely principally on empirical data. So there's a lot of asset inventory control systems out there, and those are big wins when you have it, and they can be sourced for extremely valuable data. What I mean here, though, is we cannot trust that people were already considering and had this data available to us. We need to start empirically gathering data as a balance to that. So, enumerating systems in your environment, scanning for them from a vulnerability perspective, balancing empirical data that's not based on inputs that people are manually maintaining, like inventory asset controls, and then using that as a tool to verify the validity of inventory systems if they're in place and good. And then we already talked about this. One of the areas that I think is kind of consistently an issue is modeling the lifetime. We've gotten better at the SDLC for application codes. And this is an old problem that you'd think we would have gotten better at too. But systems security, as a life cycle process of understanding secure build, our configuration management strategy, our patching strategy, our application deployment strategy, all those things that are contributing to making a secure server. Who would be responsible for that in your environment, and is it getting done? And if not, where could it be getting done? So we've got about 10 minutes, hopefully, to open it up to see if anybody has any questions about anything in this stuff, or just any commentary on issues that you're seeing. I think discussion is particularly healthy for this type of thing. Go ahead. Yeah, I won't talk specifically about the bank because I can't, but a big bank, I really do think that we cannot, banks have different problems that they've accumulated. They have different cultures. They have been, maybe they've emphasized on fast deployment over security in any way. So, and maybe, their network segmentation models are still a big factor. It is really, it's a legacy, we think firewalls are a solved problem, and they are on paper, but the actual deployments in enterprises still have issues. So you can kind of determine that, and that's what I kind of encourage is to validate what you think they are with real data. So if you want, schedule a penetration test that's kind of wide open from a retail banking branch, or start to model those perspectives and gain data on which perspectives are our biggest. Where can a person see the most attack surface in the bank, and start to model that, and you'll know quickly where some of your issues are, or at least where to focus on for more control. You can reduce those spaces too and change what you should worry about. Anybody else? Yep.
Yeah. So I work for a large bank as well, and the big problem I see because of the cultures in a large company is the lack of synergy between departments, particularly with InfoSec. How do you foster a better environment for cooperation between departments?
Yeah, it's tough, and that's what I really do encourage at least analyzing where some of the failures are coming, and not being super confrontational about it, but getting, even if it's improving your understanding on how those groups are not interoperating well, and the empirical data of here's problems that are coming from that, then at least you have something to work with management on in a situation where you're not part of management. I'm kind of very part of middle management, I suppose. But the other thing that you can do that's probably more valuable in cases where the culture is very rigidly defined is improve your personal relationships with people. We work outside of our space a lot to do this. We'll work on technology issues. If we're pen testing an infrastructure and it's not working come the time that we're scheduled to pen test it, a lot of times we'll help get it working. We'll identify just problems in, oh, this DHCP server is handing me a bad router address. So we work with them to kind of extend that olive branch and to look at problems that we're capable of helping with. And in turn, we hope that we can improve personal relationships in order to get better understanding and better interaction. So a lot of times, even if you have a cultural failure between groups, maybe you have a guy on this team and a guy on that team that work well together and are capable of fixing a problem outside of the system.
Right, in a second, it's more of a comment here. My capacity is not InfoSec. I'm a network engineer, but I have security background. Another problem I see is that InfoSec in general is viewed as impeding progress in projects, especially when you have project managers trying to hit dates. So people do their best to not include InfoSec or not apply security to their systems just because they don't want to break anything or make more work for themselves. So that's another big problem I see.
I think it's a huge problem, and that's one of the major problems that I guess is kind of the theme of this in terms of I advocate a lot for better integration so that if your network engineering group was responsible for a lot of the security stuff and just in terms of your book of business, that security in your organization tends to try to bolt on afterwards, it would be easier for you to do it. It wouldn't delay projects as much, and it'd be much easier for project timelines to account for that effort. So that's kind of why I'm an advocate of maybe not clutching to this separation of duties and extracting security as much as we tend to do. Everybody else? Going first.
Are you guys seeing in the banking sector, are you guys seeing a similar trend where basically compliance drives InfoSec? It's compliance basically is, they're the bare minimum people. And it's become, compliance used to come in after the fact to verify that you did it right.
Right.
And are you guys seeing a trend where compliance is now basically leading InfoSec?
Well, I will say that compliance, the motivator of compliance has, in many organizations, not speaking specifically about mine, motivated a better amount of spend in InfoSec, but it's also led directly to those blinders of, hey, we're only going to look at things that are in the scope of compliance. And the reality is that most things, an attacker is never going to consider the scope of appliance, and unless you expand the scope of what you're looking at, you're going to miss things that escalated attacks between systems, just system adjacencies and shared resource dependencies that you're not considering, transmission paths. Maybe your data traverses a weak network in the course of its application flow, but hey, the data is stored on a database server, and that's what you consider for the scope of PCI compliance or whatever compliance you're looking at. So it is a danger that, I see compliance mostly as a good barrier to entry for, PCI compliance in particular. It's a good barrier of entry so that not everybody's trying to do credit card processing. But the reality is sometimes it hurts large enterprises that should be thinking about security differently.
Well, we've seen a number of issues too where you end up with, if compliance says, if the legal compliance says passwords have to be at least 3 characters long, guess how long our passwords are going to be?
Yeah.
So
yeah, it certainly is also.
They'll sit back and they'll push back on you and say, oh, that's great, you think it's 8. Compliance says that it's 3, so we're making 3 character passwords.
Yeah, and compliance is certainly, and I don't mean this to offend anybody, but compliance is certainly the GED of security, right? It's the minimum requirement that we need to meet our obligation. It does not mean that we have a valuable skill in the security space necessarily.
So with PCI compliance, I've done several projects for very large organizations, and I used it to get funding for things like Active Directory. And once it was there and bought, we moved everything, you got the single sign-on, you got all that, even for our non-compliant systems, because we paid the money, so we might as well use it everywhere. So I use it as a gateway to get a lot more things in the organization that had to be there because of compliance, PCI specifically, and then it makes sense to leverage them everywhere and your overall security goes up.
Right. There certainly is a tactical value to it in spaces, and if I didn't have a high school diploma, I certainly tactically want to get a GED, and that may get me in the door where I can start solving real security problems. There's tactical leverage for it, and there's government need for it, I suppose, in terms of guaranteeing, creating that barrier to entry for places. I think in large organizations, I do agree that compliance can become an overemphasis and also introduce a lot of those blinders I talked about earlier. Joe?
Question that I have with a lot of what you're doing, I think it's fucking brilliant because you really keep pounding on root cause analysis. One of the things that I'm running into with a lot of my customers now is cost benefit analysis. You know, I understand that this is a problem, but in the span of running a business, I've got 200 problems that I'm dealing with in addition to your pretty little security problem. Why should I do this over all of my other problems? Do you find yourself having to go down that road? Cost benefit analysis, hey, if you spend $200 here.
I tend to use the unknown cost benefit analysis problems. Okay, we cannot quantify the cost of this problem because we don't know where this instance of problem is across the bank. So we start thinking class of vulnerability and grouping that. Well, then that at least gives me the ability to justify my research and to quantifying the issue as a bank issue versus looking at the issue in application X. So then if I can come up with a good case of, hey, a lot of these problems are major impacts, especially when you start to roll up the impacts into one number. And that way the bank can make a seemingly singular investment in solving a large class. That's the thing. Banks are essentially a risk management business. If you can make a good case for that, you will sell management in a bank on those type of more impactful changes. Much better than you'll sell, hey, we need to go and fix 200,000 vulnerabilities in our environment. Our systems engineering guys are telling us it's going to take 14 years of constant patching, clicking buttons and stuff. I mean, that's what loses arguments in the bank, or in a bank. Anybody else? All right, well, thank you very much.